Alright, welcome back. We have got another wonderful video to watch today. This is going to be from section 9.6 in your book. The last couple of days we've been talking about the sine and cosine curves and what they look like and how they get shifted. Now we're going to turn our attention to some other trig curves. The two we're going to look at today are tangent and cotangent. So let's spend some time right now to talk about the tangent curve, what it looks like, and all of its special characteristics. So as we go through this video, I'd like you to consider 6 questions right now. First question I want you to be thinking about is, what does a tangent curve look like? Right? What distinguishes it from other curves, obviously. Question number 2, what's this period? So how long does it take a tangent curve to complete a full cycle? Remembering that for sine and cosine that period is 2 pi, so we'll see if it's any different for tangent. Number 3, what's the domain? So what values of x can you plug in for tangent? Likewise, what's its range? So when you plug in those values for x, what are the corresponding y values that you get back? Question number 5, we're going to be talking about asymptotes today. What exactly are those asymptotes and why do they occur where they do? And question number 6, just as what we did with the sine and cosine curves earlier, how does different coefficients in the equation of a tangent curve, how do those shift the curve? What happens when you plug in values for a, b, c, and d into the tangent function? So once you have these 6 questions copied down, then go ahead and proceed to the next part of this video, which is going to jump to the graphing calculator. So have that with you right now as we do some graphing calculator work. So on your graphing calculator, just make sure everybody has the same window values to start. So as you go to your window screen right now, make sure your minimum and maximums for your x's are negative 2 pi and positive 2 pi. And then let's just make sure our y values go from negative 5 to positive 5. On the y equals screen, go ahead and graph tangent of x. And remember, your calculator needs to be in radian mode. Now, I'd like you to notice that the graph is going through 0, but it also goes through pi, and there appears to be an asymptote at pi over 2. Pause this as long as you need to kind of check this graph out a little bit. Alright, so let's go ahead and answer some of these questions right now. Obviously we know what the curve looks like now. Tangent curve is always going to go up as you move from left to right. We have what's called an inflection point. The inflection point is where it kind of does that little S-curve thing. And for the normal tangent curve, when it's y equals tangent of x, that inflection point is going to go through 0, and it's also going to go through pi. Where that asymptote appears to happen is at pi over 2. It's also at negative pi over 2. So as you kind of put those ideas together, it shows you that the period of the tangent curve isn't 2 pi, but it's pi. Everything is going to repeat in pi radians, or in 180 degrees. So that's the first major difference that you're going to see with the tangent curve. Obviously the shape is different, but the period for the tangent curve is only pi. That's a pretty easily confused thing as you start working with the different trig curves. Now you notice that those asymptotes are occurring at pi over 2, negative pi over 2. If we continue that, it'd be 3 pi over 2. So the domain of this, remember if you have an asymptote, obviously the function is undefined there. The domain is going to be anything except pi over 2 plus or minus pi times n, where n is going to be whole numbers, 0, 1, 2, so on and so forth. You can also check out the range here. You can see that the graph goes obviously off the bottom of your screen. If you continue to expand your y min and your y max, it wouldn't change. This curve is going to go all the way from negative infinity all the way up to positive infinity. So the range can be every single number imaginable depending on what values you put in for your x. So again, kind of going back to talking about the asymptotes again, what's the story with those? Why do those occur where they do? In order to answer that, you need to remember that tangent is defined as sine divided by cosine, or on your unit circle, y divided by x. So tangent's going to be undefined anytime that cosine, or your x value on your unit circle, equals 0. So if you're looking at your unit circle right now, you could see that at pi over 2, and at 3 pi over 2, and if we were continuing to go to 5 pi over 2, those are all the places where cosine or your x value is 0. So that's why your asymptotes occur there. So that's kind of your introduction to tangent curves. So how do you shift them? What's going to happen as you plug in those values for a, b, c, and d? How does the function get shifted? What I'd like you to do is copy down these following 3 equations. I want you, once you're done doing that, to push pause on the video, come up with your best guess as to what you think is going to happen when you plug in those numbers. After you've written that down or jotted it down or thought about it, go ahead and graph those on your graphing calculator. See if what you thought happens really does. If it doesn't, make that change. Make sure you understand how it's changed. And then when you're done with all that, go ahead and push play on the video, and I'll put down the answers to what really happens to these. Try it first though, just so you can see if you really do understand what happens when you plug these in. Very similar to what we did with sine and cosine, so shouldn't be too awfully difficult. Alright, so I'll see you here in a few moments after you've had an opportunity to work on these 3 graphs. Alright, so hopefully you've had an opportunity to do that. Now welcome back. Here's what I have for answers to each of these 3. For part A, the 2 is going to cause the period to go from pi radians to now it's pi over 2 radians. Alright, so putting that number in there with the x, sometimes that would be in parentheses, is going to change the period just like it did with sine and cosine. With part B, the negative is going to make your tangent curve flip, so instead of going up from left to right, it's now going to go down from left to right. The 1/2 kind of flattens it out, especially you can kind of see it as it moves through that inflection point that we talked earlier. Alright, so it kind of spreads it out a little bit. And again, your period has changed because of that 3, it divided by 3, or the 1/3, is now going to make that period 3 times as long. So now your period is now 3 pi. A lot of things going on here in this 3rd equation I had you do. The 2 out in front is going to make that curve generally steeper. So instead of having it getting flattened out like we had earlier, now it's much steeper. The pi over 4 in the parentheses with the x is going to shift it. Remember, when it's in there with the parentheses, it's going to work opposite, so this is going to be shifted to the left. Pi over 4 radians, or 45 degrees. And then the -2 is going to move the whole entire function down 2 units. Harder to see this, but you kind of look for that inflection point, kind of see where that's at. And instead of being at 0, 0, this one would be at negative pi over 4, negative 2. Alright, so I've done everything for tangent. I really would like you to try to go ahead and see if you can figure out things for cotangent. Just like if we were in the classroom, I'd be doing the same thing right now. I'd give you cotangent and let you go and explore with that. So I want you to go back to the beginning of the video, and I want you to answer the 5 questions, or sorry, yeah, I guess the 5 questions that I asked earlier in terms of what's it look like, what's its period, its domain, its range, where do the asymptotes occur, and why. And then go ahead and figure out how it shifts. You might struggle a little bit trying to figure out how to put cotangent in on your calculator. If that's the case, just take a moment here and watch how I do it. So if you go ahead and remember that cotangent's the reciprocal of tangent, so if you just do 1 divided by tangent of x, you will get the cotangent graph. Make sure that when you do this later, when you start checking to see if you're shifting it correctly, you need to put all of that function in as the reciprocal. So 1 over, and then put a parenthesis, open that parenthesis up, and that will, and put your whole entire cotangent function in. So there's your general shape of the cotangent graph. You can see that it's now going down from left to right. Go ahead and answer the rest of those questions. Talk about its range, its period, domain, all of those things. And then when you're done with that, here are 2 equations that I'd like you to figure out how it gets shifted. Again, it's going to have very similar characteristics to the tangent graphs earlier. So sketch that. Again, use your calculator to check that out. And then tomorrow we'll come in and we'll begin our discussion of class of what these graphs look like. So if you're struggling with any of this, be prepared to ask those questions tomorrow in class, whether it's just general questions about these curves or specifically about why do they shift the way that they do. And so we'll start our class discussion tomorrow with that. Please make sure you do this. If you come in tomorrow and you don't have this material done, you won't have as much to offer, or at least understand what it is that you do understand and what it is that you have some questions about. So best of luck with this. We'll see you tomorrow. Feel free to ask questions on our Facebook page as well if you're struggling with something tonight.